This is my Unit 1 video for Survey of Chemistry. I have my work written here, periodic table, and then I just had the questions pulled up for reference to make sure I answer them all. So, number 1, convert 0.97 grams to micrograms. To start, I needed to find the conversion factor between micrograms and grams. This is going to be 1 million micrograms in 1 gram. Then we set up this dimensional analysis. So essentially, we're going to multiply 0.097 grams by our conversion factor. So this is how I like to set it up because it works best in my brain this way. And then simply we're going to make sure in our conversion factor, 1 million micrograms in 1 gram, we're going to make sure grams are in the bottom on this side, while this is always on the top. So that way they cancel out. If grams was here, that would not be correct and they would not cancel out and we would not get micrograms in our final answer. So from here, we're going to multiply 0.097 grams are going to cancel out, 0.097 times 1 million micrograms divided by 1. And that's going to give us 97,000 micrograms in 0.097 grams. Number 2 is asking me what is the atomic number, mass number, and atomic mass of nitrogen. So to start, the atomic number is 7. The atomic number for nitrogen is never going to change, as it's never going to change for the rest of the elements. This is because the atomic number is equal to the number of protons in an element, and the number of protons in an element always stays the same. It is also equal to the number of electrons in an element. The mass number for nitrogen can vary. So some stable options of mass numbers for nitrogen are nitrogen 14 and nitrogen 15. One unstable would be nitrogen 13, which would be radioactive. The subatomic particles that correlate to the mass number are going to be the atomic number, or the number of protons in the element, and the number of neutrons. These two added together equal this. So nitrogen 14 would have 7 protons and 7 neutrons. Nitrogen 15 would have 7 protons and 8 neutrons, and so on. One more question was, if there are 2 atoms of an element with different mass numbers, they are called isotopes. These are called the different isotopes for nitrogen. And then finally we have the atomic mass. There's going to be 1 atomic mass for nitrogen and the rest of elements as they're listed on the periodic table. The atomic mass for nitrogen is 14.01. This number is going to be determined by the average of the mass numbers, these stable mass numbers. So, for example, between nitrogen 14 and nitrogen 15, 14 is going to have an abundance rate of 99.63%, while 15 is going to have 0.37%. So you can already tell the reason the atomic mass is so close to that 14 is because most nitrogen atoms are going to have 7 protons and 7 neutrons, equaling a mass number of 14. To solve for this average, you simply multiply the mass numbers by their abundance with the decimal moved 2 places to the left, and then add them together, equaling 14.017, or as it's on the periodic table, 14.01. Finally, number 3. We're going to answer the following questions about H2CO, or formaldehyde. So first is, what is the molar mass of this compound? So to find the molar mass, we're going to Simply add the molar mass of each of the elements that this compound contains. Molar mass is equal to the atomic mass of a number. So the atomic mass for hydrogen, carbon, and O are listed right here as I found them from the periodic table. And then simply we're going to add those numbers together, but make sure we have 2 hydrogens since the original compound contains 2. So once we add them together, we get 30.026, or rounded, the molar mass of formaldehyde is 30.3. Next question is asking me to draw the Lewis structure for this compound. So we're going to start, so I started by drawing carbon and hydrogen on 2 sides and then oxygen. And then to organize the electrons, we're going to put the hydrogen's 1 and hydrogen's 1 on this side. Each one has 1. And then I immediately connected those to carbon because they need a pair to be stable. So carbon has 4 valence electrons, so each of its 4 that's going to be around it is going to need a pair. So that's going to make 2, give 2 of its valence electrons a pair. And then we have oxygen. So we know that there's 2 more valence electrons that are going to need pairs from oxygen. So I drew a double bond and then just filled in the rest of the electrons for oxygen. So we're going to have the 2. There are 6 in oxygen, so we're going to do the 2, connect them with the double bond, and then 4, 6. So the line's going to show the bonds where the single unbonded electrons want to form a pair to become stable, and the electrons, like I said, represent the valence electrons. And it's important to note that, like I said, carbon has 4 valence electrons and it wants 8 to form an octet. So it does have 8 now. So it originally had the 1, 2, and the 3 and the 4, but now it has 1, 2, 3, 4, 5, 6, 7, 8. And oxygen also has 8 now instead of 6. 1, 2, 3, 4, 5, 6, 7, 8. My questions just shut off on me. I can't read the questions if I don't have them. Okay, so next is what is the molecular shape of this compound? So it's going to be trigonal planar, and this is determined by the number of charged clouds our center atom carbon has. Every bond, whether single, double, or triple, counts for 1 charge cloud. So, and it does not have any unbonded charge clouds, so it just has 1, 2, 3 charge clouds, and all 3 are bonds. This is what's going to make what is going to cause the 120-degree angles of the trigonal planar shape, because what we know is that basically the electron clouds are going to want to be as far away from each other as possible. This would be the more accurate drawing of the shape, and my drawing also is going to tie in with the next question, which is it polar? And the answer is yes, it's polar. How? Because, well, we know that hydrogen and carbon bonds are nonpolar because they are too similar in electronegativity to have a pole on either side. These are not 8s, they're delta symbols, and it showed the partial positive hydrogen has, the partial positive carbon has, and the partial positive this hydrogen has. So those are not going to be polar, but oxygen is more polar. It has a partial negative pole and is closer to fluorine on the periodic table, which is the most electronegative element. it's closer than the other one, carbon. So therefore, it's going to obviously have that partial negative, which makes it more electronegative, causing an unbalanced pull of these electrons. More electronegative elements are going to have a stronger pull on those electrons, so this bond is not going to have an even pull of those electrons, and that's what causes it to have that arrow or pull towards oxygen, causing it to be polar.